Hey kiddos! So now we're going to do another way of solving quadratics, and we're going to use the square root method. So I have this file and then the notes from my previous video. I have those saved in Teams. If you go to Files, it's in a different tab than the stream, and then you can download them there or look at them there to go along with me. I know you know what a square root is. It's a square root of a number is a number which multiplied by itself gives you that number. So for example, on those first ones here, square root of 36, we know that could either be -6 or that could be 6, right? It could be either one of those. So you could write it with these funky brackets showing that there's two solutions here separated by a comma. Do not put it in parentheses. That would make it look like the coordinate pair -6. That would not be correct. Or you could also say plus or minus 6 and write it in that fashion. Okay, so the next one, square root of 100, you could do your funky brackets and say that's -10 or 10. Or you could say that's plus or minus 10. Same thing with 4, -2, +2, or plus or minus 2. And then I wanted to show you this one. So think about square root of a negative number. Square root of -4. What times itself equals -4? Well, it can't be 2 because 2 times 2 is -4. It can't be -2 because -2 times -2 is +4. So it actually is 2i. I means imaginary numbers. But what you need to remember for this course, Algebra 2 is where you'll talk about imaginary numbers. What you remember for this course is that square roots, where you're finding a square root of a negative, is that there are no real solutions. That is what you remember for this course. And I'll show you graphically what that means next week. But for now, just know no real solutions when you're taking the square root of a negative number. Okay, so let's look at these. Plus or minus 11, plus or minus 4, and so forth. You guys know how to do that. Okay, but remember that, where'd he go? Where is he? Oh, square roots of positive numbers have two real solutions, a positive and a negative. Okay. So now let's talk about when you're going to use this particular method to solve quadratics. You're going to use this method when there is not a linear term or a b term, if you think of it that way. So for instance, if you solved for solutions of this quadratic equation, right here, x squared minus 4. Right now it's set equal to y. Remember that when we're solving quadratics, and again I'll show you why graphically why we're doing this, but we set it equal to 0. So we're substituting 0 in for y. So it becomes x squared minus 4 equals 0. All right, so there's no linear term or b term. So when that's the case, all you need to do is add, this one is factorable, but this is even simpler. You add 4 to both sides, it goes away on the left, and you're left with x squared equals 4. Okay, now this is squared. So to get x by itself, because right now it's not, right now it's x times x. So you take the square root of both sides. The square root of x squared is x because x times x equals x squared, right? So x equals the square root of 4, which we know is plus or minus 2. If you wanted to write it with the funky brackets, you could write it like this. Okay, so it has two real solutions. One is 2, one is -2. Alrighty. Since the variable is squared, we must take the square root of both sides. So rewrite it here. So x equals plus or minus 2. All right. So let's look at the next problem we have. Okay. So much easier to talk about this in class. But with quadratics, when you talk about solutions, you will find when we talk about that quadratics graphically, that you'll find that solutions are the same thing as x-intercepts. X-intercepts are the same things as solutions. Okay, so use those words interchangeably. Same thing, same thing, same thing. Okay, so I'm looking for the x-intercepts or solutions for this equation. X squared minus 5 equals y. All right, so I substitute in my 0 for y, so I get x squared minus 5 equals 0. I need to isolate the variable, so I'm adding 5 to both sides. So I get x squared equals 5. I take the square root of each side. So the square root of x squared is x. The square root of 5 is simply the square root of 5. That's it. You leave it just like that. Okay, you can't simplify that radical at all. All right, let's move on. So these, oops. All right, look at these. We substitute in the 0. We add the 36 to both sides, so x squared equals 36. Take the square root of each side. X equals plus or minus 6. If you want to write it in the brackets, 6 comma negative 6. It wouldn't matter the order in which you wrote them there. Okay? Same thing here. Substitute the 0 in for the y. You add the 121 to both sides. X squared equals 121. Take the square root of both sides. X is equal to plus or minus 11. Oops. Oops. All right. Goodness gracious, Julie Elizabeth. Hold on. I'm going to use my mouse to help me out here. Okay. Next one. So now it just looks a little different because the y is on the left instead. It's fine. So you plug in the 0 for the y. Then you're going to add your 71 to both sides. So x squared equals 71. Take the square root of both sides. X equals plus or minus the square root of 71. Make sure you put the plus or minus the square root of 71, because it's either the negative root of it or it's the positive root. It could be either one. Okay, last one is a little trickier. So I put in my 0 for y. I'm left with negative 100 equals x squared. Take the square root of both sides. So x is equal to, I can't take the square root of a negative number in Algebra 1. So I know, since that's the case, my solution is going to say no real solutions. They're only imaginary. You might see no real roots, something like that. And then I'll show you again next week what that will look like graphically. Okay, sometimes when you use the square root method, you need to take an additional step. So this question says, what are the roots for this quadratic equation? Alrighty, roots means solutions. Another word to mean that is x-intercepts. They all mean the same thing. Be very comfortable using those interchangeably. Okay, so I substitute 0 in for this. So now I have 3x squared minus 48 equals 0. So I need to isolate the variable again, so I add the 48 to both sides. So I get 3x squared equals 48. But I need to get the x squared by itself. So I divide both sides by 3. So x squared is equal to 16. So then take the square root of both sides. Square root of x squared is x, and the square root of 16 is plus or minus 4. So just one additional step embedded there. Okay, this one's a little bit more complex. Not really. Now it just has a fraction. I know you guys cringe at fractions. So on this one, we already substituted in 0 for y. Now I got to add the 8 to both sides. So 1/2 x squared equals 8. So now I have to get the x squared by itself. So remember, all you do is multiply by the reciprocal on both sides. It goes away on the left, which is what I wanted. So I'm left with x squared is equal to 8 times 2, which is 16. Take the square root of each side. X is equal to plus or minus 4. All right, same idea there. All right, same idea. I do want to show you a couple more actually. So let me get my cursor down here. It doesn't work very well for me. Let's stop inking for a second. Hold on. Oh, stop the press. Let's see here. So I want to do a little bit more complex with you. Since you are honors, I think you'll be able to pick it up pretty easily. Okay. Let's say I have something like this. Let's say I have, hold on, let me get my pen ready to go. Start inking. Why is it? Let's see. Start inking. Pens. I like my gray. Okay, so let's say I have something like this. The quantity x minus 3, the quantity squared, equals, let's say it equals 16. Okay. Now, I've taught you that you could expand the left side and then subtract the 16 on both sides and then set it equal to 0 and factor. Okay, that's one way that you could solve this. Okay, however, another way that you can solve this is by simply taking the square root of both sides. So I'm taking the square root of this. So in essence, what I'm doing is taking the square root of the quantity x minus 3 times the quantity x minus 3. I'm taking the square root of 16. Okay, square root of anything times itself is just whatever that number is. So the square root of x minus 3 squared is simply x minus 3. And then the square root of 16 we know to equal plus or minus 4. Okay, so now I need to get x by itself, so I get x equals, so I add the 3. X equals 3 plus or minus 4. Do not leave it like that. You can simplify it from there. Okay, so what that expression is saying, that's saying that x is either 3 plus 4, and that's also saying that x is equal to 3 minus 4. So in this case, my two solutions are going to be x is equal to 7 and x is equal to negative 1. Okay, let's do another one like that. So if I have, oopsie, get my pen again, it rhymes. Okay, let's say I have, maybe this one's not as pretty. X minus, let's do plus 4 quantity squared equals, let's do something that's not as pretty. Let's do 11. Okay. All right, so you have a quantity squared on the left and then just a constant on the right. This is perfect to use the square root method. Okay, simply take the square root of both sides. Again, what this actually is just x plus 4, x plus 4. Okay, and if you think about it, well, easy enough. So any number times itself is going to be what the square root is. So this square root of x plus 4 quantity squared is going to be simply x plus 4. The square root of 11 is simply plus or minus the square root of 11. Now I cannot simplify that radical. I cannot. So what I can do though is get the x by itself still, and by subtracting 4 to both sides. So x is equal to negative 4 plus or minus the square root of 11. And you leave it just like that. Okay, let's do another one. Let's see. Okay, let's do one. Actually, let's talk about just some radicals. Let's talk about the square root of 20. I think I did this a little bit with first semester, but not everybody had me, so you might not have seen it. Okay. Would you guys agree that the square root of 20 is the same thing as the square root of 4 times 5? The same thing. Okay. Well, that is also the same thing as the square root of 4 times the square root of 5. Well, heck, do we know what the square root of 4 is? We do. We know it's plus or minus 2. We can't simplify the square root of 5. So the square root of 20 simplified, and I'm not sure this will show up in your work or not for right now. This is just extra information. It's good knowledge to have. The square root of 20 simplified is actually plus or minus 2 times the square root of 5. All right, let's do another one. Let's do the square root of 40. Well, that is the same thing as the square root of 4 times the square root of 10. 4 times the square root of 10, which is plus or minus 2 times the square root of 10. Okay, let's do some more. All right, let's get a more complex one in there. Let's see. Okay, what about this one? What about the square root of 72? What do you think? So what you try to do is you try to come up with factors of 72 that are perfect squares. So think of factors of 72. So I think you probably quickly think of 9 times 8. Is either one of those a perfect square? Well, yeah, 9 is. Okay. Well, 8 is not a perfect square. But if you think about the factor tree for 72, what does 8 break down to? It breaks down to 4 and 2. Are either of those, 4 and 2, a perfect square? Yes, 4 is a perfect square. So not only could I break it down by 9 times 8, I could also break it down by 9 times 4, which is 36, times 2. Okay, so I'm going to show you both ways. Now, if I had done it like how most of you probably thought there, most of you probably thought, well, it's going to be square root of 9 times the square root of 8. That's going to get me plus or minus 3 times the square root of 8. But you always have to think to yourself when you are done simplifying, can I simplify the radical that's left any further? Okay, so can I simplify that any further? And in this case, you certainly can. So it becomes plus or minus 3 times the square root of 4 times the square root of 2. Okay, so then you're left with plus or minus 3 times the square root of 4 is 2 times the square root of 2, which becomes plus or minus 3 times 2 is 6, and then times the square root of 2. Okay, that is if I had started like this. However, if you are able to think about and find the greatest common perfect square factor of this number in the radical symbol, it's going to save you a step. So if you had thought initially of 36 times 2, so let me use a different color of ink for that. So if you had thought initially, well, the square root of 72 is the same thing as the square root of 36 times the square root of 2, well, then you would have come up with what we ended up coming up with at the end, plus or minus 6 times the square root of 2. Okay, so this is a little lesson on radicals as well, but being able to solve quadratics using the square root method.